Now consider the current is available in three different forms. One is called as a line current, second one is surface current, and the third one is volume current. Okay. Here the line current means, let us consider the current flowing through a thin wire. This is thin wire. When current flows through a thin wire, the current is called as a line current. Okay. Then what is meant by thin wire? Thin wire means, if we consider radius of the conductor, radius of the conductor tends to 0. Our radius is approximately 0. Okay, very small. Then the conductor is called as a thin wire. Okay, so current flowing through thin wire is called as a line current. Okay, next one, surface current. Here the name itself explains that the conductor will be in the form of surface or sheet. Okay, so here the current flows in this sheet or surface. Okay, so because the current flows in the entire sheet from left side to right side, so this conductor is called as a surface current. Okay, now consider width. This is the width of the sheet or width of the conductor. Okay, now observe this one. When current is flowing through this sheet, the current is crossing width of the sheet or area of the sheet. Actually, if a current is crossing the area of the sheet, then diagram looks like this. This is the sheet. When current flows like this, then we can say that current is crossing the area. It is crossing the area. Yeah. So current is crossing the area if we have diagram like this. Okay. But here in this diagram, what is happening here? The current is flowing in the entire sheet. It covers entire sheet. So it is called as a surface current. But when current is flowing in the sheet, it is flowing or it is crossing only one side of the conductor. Okay. That is called as the width of the conductor. So here the current density or surface current density is defined as the current crossing unit width is called as a sheet current density or surface current density. Okay. So here we define an important term, surface current density. Surface current density denoted with K or Js. Okay. So total current flowing in the sheet and the width it is crossing or the side length it is crossing, okay, is I by W. Okay. So current is measured in amps and width is measured in meters. Okay. Here you should observe that. So current density, sheet current density is measured in amperes per meter. It is not amperes per meter square. Okay. It is a simply amperes per meter is the sheet current density. Okay. So similarly, let us consider volume current. Okay. So for consider the volume current, let us consider a solid conductor. This is nothing but a solid conductor. And current enters the conductor and leaves the conductor. This is I. Okay. Now if you observe this one, the current is flowing in the entire conductor from one side to another side or one end to another end. While current is flowing in the sheet, the current is crossing the width of the sheet, that means area of the sheet or volume of the sheet. The current flows in the entire volume, so it is named as volume current. Okay. While current is flowing in the entire volume, it is crossing only cross-sectional area of the sheet. At any location you observe, at any location of the conductor you observe, the current will cross only cross-sectional area of the conductor. Okay. So I consider this one as cross-sectional area of units A meter square. Okay. So current flowing is I and it is crossing a cross-sectional area of A meter square. Okay. So then we can define volume current density. Volume current density. This volume current density is denoted with J, given by the total current flowing divided by cross sectional area. Cross sectional area, that is I by A. Okay, and what are the units for this term, volume current density? The current is measured in amps, area is measured in meter square. Okay, so that means here it is different from charge densities. The surface charge density is measured in current per unit width, that is amperes per meter, and volume current density is measured in current per unit cross section area with the units amperes per meter square. Okay, so from this, what is the current I? The current crossing any cross sectional area is a current density into A. How do you find this area? If you know this cross section is a known shape, we use the formula. Okay, so if it is a cross section is some random shape or some arbitrary shape, then we need to apply surface integral to find this area. That is surface integral of J bar dot ds bar. Okay, so another very important equation, the relation between current and volume current density is through the surface integral. Okay, so current is equal to surface integral of volume current density is very important equation we use in the electromagnetic fields. Okay, so these are the three types of current distributions: line current, surface current, and volume current. Okay, now let me explain what is the Maxwell's equation from Ampere's law. Okay.